Perfect. So hi, everyone. My name is Chris Doran. I'm a technical sales specialist for Global Test Supply. Thank you for joining us for our webinar today, brought to you by Global Test Supply University. Today's topic is electrical equipment safety with Fluke. We'll be covering a decent amount of information over the course of the next 40 to 45 minutes or so, and we'll have time at the end of the presentation for Q&A. That being said, if you do have any questions that come up, passing a slide or a specific topic that's of interest to you that piques a question, please use the chat feature or the question feature and get your questions in throughout the presentation. Again, we'll take them in the order that they come in at the end of the presentation. So Global Test Supply and Fluke have been working together closely for many years. We pride ourselves on being a leading distributor of Fluke here in the US. This is a result of our dedication to offering you our product expertise, our customer service, and our competitive pricing. Getting started today, today's webinar is presented by Sean Silby from Fluke. Sean has been with Fluke as a product application specialist for the past 7 years. Prior to working at Fluke, Sean was in the HVAC industry for 15 years, working on residential and commercial applications. In addition to his wealth of technical product experience, Sean has become an integral part and member of Fluke's Clean Energy Initiative, focusing on tools for the EV charging and solar segments. So Sean, I will turn the presentation over to you.
Thanks, Chris. Yeah, thanks everyone for attending. I'm gonna go ahead and get started here. Like you said, we've got a lot of information to cover in a short amount of time. If you have any questions, please type them in and we'll get started. Just for bandwidth capability, I'm gonna go ahead and turn my camera off. And let's go ahead and get started. So the whole conversation here is about safety. Safety in the workplace, safety out in the field. Literally 5 to 10 arc flash incidents happen every day in the US. That's incredible. 77% of recorded electrical injuries are due to some type of arc flash incident. And every year, more than 2,000 people are admitted into burn centers based on arc flash burns. It's incredible. If you go out to Google, go out to research it, there's a lot of videos of just arc flash incidents that were recorded on video and how quickly and how fast they happen. It's just amazing. When we talk about the arc flash, we talk about that potential current running through it. I like to use this slide because it talks about, you are going to be that ground if that current is running through your body, to get that shock. There were studies done years ago, actually in the military, where they would simulate, or put 1 milliamp in, and the soldiers would say, well, I feel this light tingling sensation. And as they slowly increase that energy or that current, they would report back. 5 milliamps, 6 milliamps is really what we see our GFCIs here in the US, in our bathrooms, in our kitchens. Those are kind of where those are set. But as we increase that milliamp current, the pain gets even more. We lose muscular control. Maybe we start losing our respiratory extreme pain, even if at that 99 milliamps. And at 2 amps, 2,000 milliamps, you could have cardiac arrest, internal organ damage, and even death could be probable. It really amazes me that in the US, typically our breakers at our distribution panel are at 10 amps. They would not trip unless that 10 amps was done. So you could complete that circuit and potentially have a fault running through you into that type of situation. So it's incredible that just having this knowledge and knowing kind of those levels of that current. So when we start talking about this, we talk about arc flashes. What is an arc flash? This is all about safety. We're kind of going to go in through some definitions of what that looks like and hopefully how we can step away from this. An arc flash is where it's either a phase-to-phase or a phase-to-ground short circuit. The current could literally pass through the air. It's where, ionized air is a great conductor of this. And as you can see in this picture here, these test leads are there. There's a lot of exposed metal. They're touching high voltages, high current, and then arc flash begins. And these happen within less than a second. This is where all that matter and all that vaporation takes happening. From that arc, we can have an arc blast. Now that arc blast is really taking, it becomes an explosive nature at that point. You can see in this cabinet there, that arc blast, because of that potential energy, there's intense heat involved with that. Obviously, a shock wave of energy is running through because of the amount of intense heat. Now we have molten metal, shrapnel, obviously a blinding light. That metal is now creating gases, and it's a toxic smoke. And all of those components had caused that arc blast to happen. And it's all based on that potential energy. So what causes this? There's really several ways or several things that we can look at, whether it's racking in a circuit breaker. Sometimes the little ones, you don't really necessarily see it in uh, residential and some of the light commercial, but some of the larger industrial is where we've seen really massive just arc blasts happening where they're racking in a circuit breaker. But there could be loose paneling, even in a 240-volt split phase. If you had loose wiring, loose paneling, you would create an arc fault, an arc blast happening in that. Sometimes if you're removing a panel, maybe there was loose wire, loose screws, and that would cause that. They short out on the line. Maybe you've already got that open and you're working, and a hand tool accidentally slips down across the two phases. And that's where we see another situation of that nature. That metal crosses the two and happens. Even using incorrect test probes. That first picture I showed you had a lot of exposed metal. It allowed that potential energy to run across the two of them and cause that arc fault, cause that arc blast. And then even sometimes the tools themselves, like a measuring tool like a DMM, if you're running across right, not the correct meter for the environment, that could potentially also cause that fault and that blast to happen. So when we go into our meters, meters are designed to handle that. And Fluke's a meter company, so I am going to talk about Fluke and Fluke solutions during this presentation. And part of that is like having the test leads in the right position. That would obviously cause some type of arc fault or arc, something to happen of that nature. So having a meter, if you have the test leads in, maybe in the current position, you think you're in the voltage one, we'd want to have a lead indicator or something on that. But typically when you're measuring ohms, continuity voltage, you got the test leads in the right position. That's kind of a key win. But again, knowing where your meter and knowing where that is, that's crucial. Older meters, they can't handle that type of voltage in an ohms position. So kind of know what your meter is. Now, all of this is really playing on the guidelines of the NFPA 70E. That's safety in the workplace. If you get an opportunity, go out to the NFPA website. I've signed up with them. You can look at documentation for free, whether it's just the NFPA 70E or the National Electric Code or some of the other standards that they're referencing. But part of that is safety in the workplace, maintenance of your safety equipment, requirements of special equipment in that, and just even installation requirements on that. But a great resource when we start talking about safety, go out to the NFPA. Part of that standard is PPE. PPE is crucial. Now, PPE could be your glasses, your safety glasses, maybe a hard hat, obviously steel-toed boots, depending on the environment, or gloves, hearing protection. But when we start working with electricity and the potential energies around there, that's where our category rating can actually increase, and having the correct gear on. Cal 1, I can see this at times, it's cotton jeans, burn material on your shirt. They sell category Cal 4 shirts all over the place. Where we get into higher voltages and higher currents and that potential energy, you might need a category 4 rated outfit. Now, this is where you look like Darth Vader. You're fully exposed, fully covered in, you got your arc flash gear. So just kind of knowing what your potential and where you're working would really base that PPE and where you're at. So talking about that, if you've got some type of exposed electrical outlet, some distribution panel that you're working on, there are boundaries built into the NFPA of where you need to be at. You know, the farthest distance away is that arc flash boundary. We would set that up based on the potential energy of that distribution panel. What does that look like? Where they necessarily wouldn't need to have the full PPE on to walk around that. We actually set that boundary up. Now, there's also a limited approach boundary. And this is where if you were qualified and you were able to get closer into this environment with the correct PPE, you could cross one boundary into another. And then finally, that restricted space. This is where you're going to be exposed critically to to your conductors. Even working at your breaker in your house. If you think about it, once you remove those panels and your electrician's working there, that restricted space is really the closest one. So knowing those limits, knowing the correct PPE to be using is really valuable in this. You know, and your test instruments. So not only did we talk about clothing and knowing the correct PPE to have on, but part of NFPA 70E says that your test instrument is PPE. So having the right equipment to be able to work in that, knowing that your test leads and your meter qualify as that PPE, they should be visually inspected. They need to work correctly. You need to validate that it's working properly before you go in and touch those. I've heard countless times about people being shocked because their meter wasn't working correctly. They thought that the circuit was dead. They went ahead and took their gloves off, they started working on it, and then realized that it was actually a live measurement. So how do we even test our DMM? How do we check that? Well, part of NFPA 70E says we need to do a live dead live test. We're validating that the meter is going to work correctly. So we do this by going to a known voltage source. We know that this outlet is 120 volts. We're going to use our DMM. We're going to check it. We're going to see 120 volts on the line. Now, also part of this is to go back to the breaker and turn that off. And we're going to check that circuit again and know that our meter read 0. And then finally, we're going to re-energize that line, go back to the meter, back to that circuit, and validate, yes, our meter is truly working correctly. We can go through our day and make that measurement. But what happens if you don't have a known voltage source? There's actually a lot of times where you're out in your truck, you're out in the field, maybe you're on a construction site, you're still running and doing some stuff. Maybe there's a voltage drop out there for you. There's not a good way to get a known voltage source on that. That's where you can use a proving unit, like the Fluke PRV240. It actually generates 40 volts at almost 0 current and allows you to do a dead live test on your meter and validate that it's working correctly. So again, learning the safety procedures, learning how to mitigate some of those safeties that could potentially cause that arc fault, that problem. This is a great way to do that. So the bottom line, really, again, it's safety first. You know, when possible, if you are working on those energized or de-energized lines, do a lockout tagout. Make sure that you've got that. So you've got it locked out, you've got the key. Nobody can come and re-energize that line as you're working on it. And maintain your tools. That's really appropriate on this, you know. Make sure your safety glasses are good, your insulated tools, your insulated gloves, all that arc flash rating and your shields and your suits. That's all part of that. And it's part of the NFPA 70E, you know, making sure that those are maintained. You know, one of the key ones when I was out in the field, I actually, for brief time in life worked at a utility plant. I was a steam-driven operation. We never worked alone. We always had a buddy system out there, and if there was ever a problem, something happened, it can be difficult at times. When I was in HVAC, I worked alone a lot, but they knew where I was going. They knew I was checking in. So again, don't ever work alone. And then follow those safe measuring practices. Make sure your techniques. One of the great techniques that I've learned through time is that typically when you're doing a voltage check with your DMM, you always want to put the black lead on first, and then go to your ground possibly, and then go use your red one to hot. And then when you're done making your voltage measurement, you pull off your red, then you pull off your black. And that could work even with split phase or three phase or whatever you're looking at. But if you always just know that you go black on, red off, black off, it's just good practice. And then always do that live dead live test. That's always a key one knowing. So, part of manufacturing and part of knowing, because a test, your meter is part of that extension of your PPE, is making sure that it was manufactured correctly. The IEC 61010 is a standard on low voltage test measurement equipment and control equipment. This is basically meters and clamp meters, etc., that will measure under 1,000 volts. Once we get above 1,000 volts, that actually becomes medium voltage. So if you're working on 480, you're working on 600, say three-phase circuits, that's under that 1,000-volt range. And we just want to make sure that the meter that you're working with, or the company, whatever that looks like, followed that IEC 61010 standard. That's really a key win. You're going to have the right meter. And why is that? Because part of that is transients. Not too many people know about transients. Transients are actually a spike in the sine wave that's coming out. If you're working on, say you're working on 240 volts, you could actually have an 8,000 volt transient run through that under 100 milliseconds. Literally, they're very fast. It's invisible. Half the time you don't even see it. But if you happen to be touching and making a measurement at that time, you're in the circuit. It could literally go through your meter. So we want to make sure that you have the right input protection in that meter. And what causes that? Could be inductive gear switching on and off. Maybe there was a malfunction in equipment. Maybe there was a utility load that was switching at the time as well. Even adjustable speed drives can cause some of those transients. And it's pretty obvious if you had a lightning strike, yeah, that's a lot amount of energy. I think I've seen Back to the Future. We've all seen Back to the Future. Yeah, it's a massive amount of energy that's going to be running through that to cause that type of transient. And that's all part of that is learning your category ratings. So we talked earlier about your PPE category ratings and the potential energy you were working around. What type of PPE should you have on to keep your body protected? But when you're out in the field and you're trying to choose a meter that might be appropriate to that, we got to know what category environment we're working in. When we think about category 4, we think about utility. This is on the utility side. This is where we don't have a lot of protection out there. So there's a lot of potential energy out there on those main conductors. But once we get into that distribution panel, we start breaking that out and distributing it. That's where that category 3 environment is. And that could even be in, single phase commercial lighting. And then most of us know that category 2. It's really those single phase receptacles, something in our houses, where we're just getting that category 2 environment. So knowing those voltages and knowing your category environment is huge. Now I like to throw this in because solar is really taking off. Renewable energies are really, it's a conversation globally everybody is having. If you're working out in the solar field and working on their arrays, those are considered a category 3 environment. It's a fixed system. It's going through your inverter. Once we go through the inverter and even get into a step-up transformer, we're back out on the grid. So we're back into that category 4 environment. Once we've gone through that, go back into the house, we've now gone back to our category 3 and category 2. The reason why I say this is just know your category environments. It's really critical when we start talking about which meter should I use, appropriate for the job. So again, know that the voltage ratings of where you're at and what you're doing and the category rating of what you're doing is typically what happens with a category 3 meter that's rated for 1,000 volts. That can withstand an 8,000 volt transient. That spike we were talking about earlier, very critical. It's actually safer than a category 3 600 volt meter that can only handle a 6,000 volt transient. So the bottom line on this is just really know where that measurement category is. You're going to see that on the meter. Hopefully it's going to display it because you know exactly where you're working. When I was out in the field working as an HVAC guy, it was typically 120 volts or it was 240 volts. There was times I would get into 480. You're up on a rooftop working on a package unit up there. But again, you kind of understand where you're at. But knowing that category rating is really critical. How do you find those markings? Again, most DMMs, whether it's Fluke or others, should have somewhere on the meter the category rating that it is for. You can see here on the input jacks on the left, this was rated for category 3 1000 volt, category 4 600. And even some meters can handle a category 3 600. So kind of again, knowing where that is on your meter, look for it. It's just more knowledge will make you safer out in that field. We even have, speaking on that solar side of it, and higher energy, higher voltages, we now have a category 3 1500 volt rated clamp meter. Again, it's all about that safety and being out there. Also too, I would recommend that with manufacturing of meters, know how the meter, there's a lot of safeties and stuff built in. Typically the documentation, when I see it, a lot of times I'll go through it. Sometimes it goes into a filing cabinet. I've got stuff to do, but really take the time. Look at some of the safety information that the manufacturers are giving you, because it's really going to allow you to better understand the limitations of your meter and what you can and can't do with it. Now, the reason why I'm saying all of this is that some meters, you don't find a rating on it anymore. Here are two great examples. There are older Fluke 70 series meters, really tried and true. They're underrated. They're actually not rated for some of the voltages at that time. And the mechanics and the electrical components have changed during that era as well. Even the original 1988, the 87 series, it's insufficient ratings on that. Really any meters prior to 1977, they don't meet the code that's out there. So with that being said, I hear this a lot at trade shows. I'm out there, somebody comes by the booth, they say, "Hey man, I love your meter. I'm actually using the meter my father gave me." Or I've even heard, "I'm using the meter my grandfather gave me. It's a Fluke and it's still going strong." But I have to have this type of conversation with them that, the safety ratings of that meter have changed. And this really doesn't qualify for some of the voltage levels that it was at. So just kind of know what the rating is of your meter. That's really kind of the key conversation, because again, it's all about safety. When you talk about manufacturing of a meter, the standard says, hey, you need to do this, but sometimes the meter's not tested for it or inspected for that compliance. So look for markings on your meter that are, say, UL listed or CSA listed, Even in other countries, you might see VDE and TUV. These are compliancy standards that third-party organizations have taken a meter and tested it and made sure that it does meet that IEEE 61010 rating that'll handle that. And then you can see on the back of this meter, it's actually stamped in the plastic. Again, know what you're working with. Look at your clothing, look at your meter. These are all part of the tools that's going to keep you safe. And it's all about the design. I mean, literally, we want to make sure that the meter is designed correctly, that's going to handle the voltages, those over voltage transients that might happen during that time. You know, Fluke actually devotes 10 to 15% of it, all of its components exclusively just for protection to handle that. I like to tell a story about this. I was working and I got an email, and it was about a guy who he was out on an oil platform out on the Gulf. He sent me a picture of his meter and it was black. I mean, it was black. You could barely see any yellow from the holster. And he had said that one of his technicians was trying to measure that it was an 87.5. It's rated for 1,000 volts. He plugged it in, put it in volts, and went to make a measurement. Unfortunately, the technician didn't realize he was on 4160. He was actually measuring 4,160 volts. The meter withstood the shock from that measurement, and that technician was able to walk away unharmed. There was an arc fault. I mean, obviously there was a condition, but again, knowing the manufacturing, knowing that it's based on those standards is huge. You want to make sure that you're using the right tool for the right job. Now with that, and we talked earlier at the beginning of the slides about potentially sometimes having your test leads in the wrong position, making a voltage measurement when the meter thinks you're measuring a current. That'll go through the fuse, and that fuse hopefully will pop. You want to make sure that you use the right fuses, make sure it was designed for that meter, because that amount of energy can literally be up to 1,000 degrees Fahrenheit. And having the right fuse in there is really going to save you. I can't tell you how many times I've heard and sometimes seen somebody's taken like a paper clip or a nail and put it into where a fuse would be. It's wrong. That's not the way it was designed. You've now put that situation completely unsafe for yourself and for the people around you. Fuses are designed to handle that energy and to break if they need to. So be sure to put the right fuse in your meter when you need to. And also too, let's talk about test leads. Make sure that you have the right category rating for your test lead. This should be stamped on the lead itself. You should be able to see what your category rating is. Are they rated for 1,000 volts? Maybe they're only rated for 600 volts. But again, part of this too is inspecting them, making sure that your test leads are not wearing down. They're not fraying in that bottom left picture where you can actually see exposed metal. If you were touching 480 volts and you happen to touch that, you would get shocked. There's a safety problem there. You know, some test leads actually are double layered. As they start wearing out, you'll start seeing another color underneath that initial layer. It's time to replace them. Make sure that nothing's damaged. The test leads are working correctly. The finger guards are there. No insulation damage. You know, one of the key one too is your test probe. The ends of it. Make sure that they're not broken or they're, you know, arced. I've seen it. That arc happens and you've got a jagged edge out of that probe. One of the key conversations on this too is the exposure of the probe and what category rating it puts you in. You know, if you have exposed metal on your test lead like that, it lowers your category rating. You really can't handle that 1,000 volts at that category 4. You're now 1,000 volts category 3 or even category 2. So that's where caps come into play. That's where maybe a twist guard, something that we can minimize the exposure of the metal at the end of your test lead. That way we don't create that arc fault or that arc blast. Like in that original picture where we saw the two test leads running across and that was going, causing that blast. So just make sure that you're using your test leads correctly. You've inspected them and they're category rated for your environment. Now also too, there are times where you might need to use a non-contact voltage detector. These are great. These allow you to at least verify that you have voltage there. The light comes on, it detects it. Sometimes they will buzz depending on which model you have, but it is a good indicator that you might have live voltage present. But if you're looking for the absence of voltage, you always need to use a test lead. Make sure you do a contact on it with your test leads to verify that the voltage is down, because what if you have shielded cable? Maybe it's not reading it, you get a false positive, and then you get shocked. So kind of the key one on that. And all this is really educational. Hopefully everybody takes some information back from this to say, hey, I need to be looking at my test leads, need to be looking at my meter more, and just making sure I'm working in the correct environment. Now, think about that non-contact I just talked about, and we'll introduce FieldSense. FieldSense is a Fluke technology. It basically has a sensor built into the meter itself, and it will measure voltage and current without using that metallic contact. This is a safer way of making voltage and current measurements without ever having that arc potential there. The T6, the 377 and 378 allows you to make that non-contact voltage measurement without using your test leads. Again, a safer way of doing your job. Also, too, key is trying to stay out of that arc flash zone. There's now tools that have Bluetooth built into them, or Wi-Fi even. So Fluke Connect is a Bluetooth capability. Any meter that says FC on it, we can put that meter in, step away and use a smart device, an iPhone or an Android phone, and see the measurement on the phone itself. Again, we've energized the line, we're staying out of that arc boundary of potential energy. And some of these too, you can be able to, as you can see in these pictures here, multiple different ways of making those measurements and working with those tools. Now, also too, there are remote configuration devices like an insulation tester, where we can set this up and again, doing high voltage insulation tests, work from a distance using our smart device and configuring and starting and stopping a test, again using that Fluke Connect. But the theme here is keeping you away from some type of potential energy, keeping you away, that way you're safe on it. And then on this too as well, you can even save up to 10 or look live up to 10 measurements while you're doing it. So we've kind of talked about staying away, whether we're making those voltage measurements, those current measurements, potentially how to do that with using Bluetooth devices. But another great tool is an infrared camera. Now, again, this is allowing us to look for heat signatures, maybe components that are in there that are starting to fail. Thermal imagers are great for looking at potentially unbalanced loads, whether it's a voltage or a current unbalance. You're going to be able to see that with a thermal imager. And you're able to do that from a safe distance. Seeing those components, being able to open up that panel and look at it from a distance and start recording and doing some analysis on that. Here's some great pictures that we've been able to pull, because it really does help you troubleshoot electrical problems that could potentially cause a fault later, or whatever that may look like. A lot of these are on circuit breakers where you can kind of see some hot current running through it. But even from a distance, you can kind of see on this far right picture some transformers. and they can see what's happening on that and potentially energy or some type of fault that might happen with that. But again, a good way to see if you've got excessive current, those unbalance of your three-phase systems, just a great way to look at that. So one of the fault conditions what we talked about earlier was potentially taking a panel door off, and that could cause an arc fault or an arc blast. What if you had an IR window? What if I was able to take a thermal imager and look through this device and scan all that safely? I didn't have to put my PPE on. All I had to do was open up the window door and scan with my thermal imager. Again, another safer way to do your job and make those measurements. Some of them you can even actually scan an asset code and then data log that, capture your image, and put it into a profile. Again, a safer way of making those measurements. So on this one here, part of NFPA 70E states that all your employees should be trained to do their job. So really selecting that instrument to do the job right, demonstrating how to use the tool to do the job right is really critical. If you were trained, you should then know how to interpret your results and see that, and understanding the ratings of your test instrument. What does that look like? Those are all key, components, part of that NFPA. So I like using this image because it's really an advanced power quality meter, and you have to be trained in order to do that. You'd have to be trained to set that up and know your environment. So it is a great tool to be able to do that. So really, we've covered a lot of material here. We're trying to keep safety at mind. You want to stay up to date on those safety standards and those codes. Go out to the NFPA website. It's free. Just log in and you can look at what the latest standards are on that. And using the right tool. Make sure that you select the right tool for the right job. Know your category ratings. You're obviously knowing that your voltage ratings are there, but knowing how to blend those two and know that. And knowing the PPE category ratings that you should be using when working on those situations and in those environments. Do an audit test on your tools. As we mentioned earlier, make sure you have the right meter for the right environment. If you've got those older DMMs and clamp meters, you may want to look at retiring them based on those category ratings and get into some newer ones that are safer and they're going to withstand that transient. But make sure they're operational ready. Do that live dead live test when you're out in the field. And then if you need to order parts, test leads are cheap. Again, it's an extension of the energy that you're making that measurement to do your job. So replace those test leads at a regular interval. Make sure your fuses are working correctly because again, that is a safety feature in that. And make training and even briefings part of that daily workflow. I know in some environments they do a weekly safety meeting, just looking through and keeping safety at the top of the mind. So I know we covered a lot and I wanted to make sure, I think I even went a little fast on it because I just wanted to make sure we got through everything very quickly. So if you have any questions or any comments, please let's take them.
All right, perfect. Well, first off, Sean, thank you very much for the presentation. As you mentioned, a lot of stuff we covered today, a lot of great material. We do have plenty of time for questions, about 15 to 17 minutes, so that we can be respectful of everyone's time and finish off at the half-hour mark. So before we get there, a quick note on product-specific questions or questions related to your specific application that we may or may not have enough time to get to precisely for your individual needs. For those questions, for those needs, we're going to encourage you, and I encourage you to go to globaltestsupply.com. There you'll find our list of products, pricing, availability, technical data sheets. More importantly, you'll find all the various ways you can contact our technical sales team. So, you know, if you have a question, if you're using an old meter, one of the meters that we discussed during the presentation today, and you realize, you know what, it's not categorized for your specific application and you need help finding a replacement, please go to our website, globaltestify.com. Either go through it, scroll yourself, or you can contact us and we can definitely help put the right meter in your hands, get you spare fuses, leads, anything and everything that you could possibly imagine. So without further ado, we do have a few questions that came up. First, which this is a little bit more housekeeping. For all of you who are interested, and Jason specifically, we will be posting a recording of this webinar on our website, on the training section of our website later on, either this week or next week. So if you have any colleagues or anything like that who may have missed the presentation, you'll have full access to it in the coming days and weeks. Let's see, we're going to bring out another question here. Okay, okay, so we talked this, you know, this is primarily electrical safety. Is there an advantage of using an intrinsically safe DMM, for instance, in a potential in our arc flash area? Will that provide any added safety or bonus coverage?
No, what a great question. Yeah, so intrinsically safe means that a meter is designed when you're making electrical measurements that there are little sparks happening internally to the meter. You don't see it, it's not causing any damage, but there could be potentially a little spark when you're making a voltage measurement. If you were in a hazardous zone where potentially, say it was oil and gas, and you had gas fumes around, if you were making that measurement without an intrinsically safe unit, there could potentially be a fault. There could be a blast happen because of that internal spark. So that's where an intrinsically safe meter is very valuable. There's additional safeties built into that doesn't allow that spark or anything to come out of that meter in that hazardous zone. Now that doesn't help you with potential to arc faults or arc blasts. If we're looking at measuring just regular voltage measurements on there, that's where we take all the other considerations into this, making sure our test leads are right, making sure that we have the right meter, we've done through those safety checks to mitigate as much as possible that other measurement of doing that measurement. Does that make sense?
Oh yeah, definitely. Speaking of leads, it's a question that I know our team gets often and relatively often. Will a fuse test lead increase the category for the lead itself or for the instrument being used?
No. So theoretically, your test leads and your meter are going to be pretty much matched to that. I know with Fluke, our test leads are category 3 1000 volt, category 4 600 volt, but that potential energy, even though your test lead could handle it, your meter couldn't. So it's not going to go, it's not going to save your meter. Now with fused probes, that's a different story. I mean, the fuse itself is trying to save the fuse within your meter. A lot of schools will do this. So if you got an education one, you've got students, maybe the instructor doesn't want to necessarily break into every meter every time to change the fuse in the meter. They'll try to put an inline fuse prior to that. So that's what he has to replace. But that doesn't change your category rating. It's actually just that saving that inline current running through the meter itself.
Perfect. Jason, for your follow-up question, there are other videos, webinars that are available through Global Test Supply and Fluke directly. I'll encourage you at the end of the presentation, there is going to be a quick survey that you can fill out. If you're interested in more topics, including ones directly on insulation testing, etc., please add it in there, and we'll be happy to bring it to bring a webinar up in the future for that. Let's see. We still have 10, 12 minutes or so available for questions. I know some people, you're only going to think of questions once the webinar is over, as Murphy Law would intend. But we do still have time here, so please take advantage. You know, we have Sean connected with us, and he's happy and willing and able to answer any and all questions that do come in. So we gave here.
I would like to make a quick comment, Chris, just about like category rating. And there was a section on there with the safety information guide. Most meters are designed for 1,000 feet above sea level, 2,000 feet above sea level, and the creepage and clearance is based on that for its category rating. But maybe you're working in high elevations, maybe you're working above 2,000 feet. That actually changes your category rating and drops it down. We no longer are that Cat 3 1000 volt. We're now Cat 3 600 volt because there's less air, we're at a higher elevation. We need to take all of this into consideration when out in the field and making those measurements.
Absolutely. So nothing's come in so far. Just a quick reminder, if you do have anything last minute, please, you still have time, punch it into the question or the chat feature. In the meantime, I'll remind you once again that this webinar, as well as previous webinars, are available to anyone and everyone. Simply go to globaltestsupply.com. On the header bar, you're going to see training, and you can go there and find upcoming webinars and past webinars, and the recordings are free of charge, and you have full access to that. Okay, Phil, thank you for your question. We might be able to answer it here. It's very application specific, Sean. So Phil works as a technician. They work on inverters that have a 900 volt DC bus capacitor, or bus capacitor circuit, I should say. Do you happen to know what category that would fall under?
Oh, that is a good question. So I would probably call that a category 3 because you're on a bus, you're on a VFD drive, it sounds like, right? Or a bus bar. Yeah, I would definitely call that a category 3 environment. Any voltages that are that high, I would push it to the higher level. No matter what, think about it on that safety level wise. A higher category rating is going to give you more safety. If you're working in this environment, I would obviously push to a category 3 1000 volt, category 4 600 volt type of meter. That additional, that category 3 1000 is going to put you in the right area.
That's perfect. So once again, as a quick reminder, as Sean mentioned throughout the presentation, after we've wrapped up here, go home or check your meters, see if they're rated properly for your application. If you have application specific questions like that, to make sure and see whether or not you're using the right meter, please go to globaltestsupply.com, find the contact us section. You can contact us via phone, chat, email. We are available. We have a big team of product experts and technical representatives who are able and willing and ready to answer any and all questions that you have, as well as if you determine that you do need an upgrade or a change in meter, we can definitely point you in the right direction. So on that note, we have nothing that has come in so far, so we will be respectful of everyone's time. So Sean, a very big thank you once again for the presentation. Very informative, a lot of details that we covered. It's greatly appreciated. And we thank everyone who joined us today for participating and being a part of this webinar. So on behalf of Global Test Supply University, thank you very much for attending. We are available to assist you in any way. As mentioned, globaltestsupply.com, get our product, pricing, availability, technical data sheets, manuals, and any and all ways you can to contact us. Mentioned earlier at the end of the webinar, there will be a short survey. Please complete it. It takes about a minute and a half. Your feedback will help us improve these webinars as well as bring you topics that are of interest to you. We're currently working on our 2023 schedule, so a lot of time to be able to prepare and bring a lot of great webinars to you. As mentioned, we do have upcoming webinars as well as we have previous webinars all posted on our website, globaltestsupply.com, the training section. Visit there, all the recordings are there free of charge and you have access to them all. And don't forget that as a thank you for attending today's webinar, your name will go into a draw to win $100 on your next online purchase. The winner will be announced on our social media channels, so please be sure to check us out there. Once again, a very big thank you to you, Sean, and a thank you to all. Have a great rest of the day, and we'll see you soon.
Thanks, everyone. Be safe.